Hey folks, I guess we are live. Let me just check if everything is working as expected. Give me a couple of minutes before we dive into the discussion itself. Just give me a second. So, okay. Oh, I think this should start, right? I started the stream. Okay, so just give it a minute or so. I think it will start. So, oh, I can hear myself. So, I hope everything is cool. So I'm streaming at my full resolution, which is 4K. Somebody's asking about the stream at 1080p. Actually, I'm trying to stream at full speed, which is, I'm actually streaming from my computer at 4K. But the problem is, I think because of this lockdown, where most people are working from home and things like that, there is a limitation on, there is a request from Government of India to stream at a slightly lower resolution. For example, I get maximum 720p. Even though I can do it at, even though I'm sending the stream to YouTube at 4K, it's only, I'm able to see my stream only at 720. It's not letting me go anywhere above 720. So unfortunately, I've seen this online also. So it's limited by Google and YouTube and because of suggestions from Government of India, right? So yeah, so that's the limitation, can't help it. Okay, so I'll take a few questions before we dive into the discussion itself. I have my whole worksheet today also. Okay, so let me try. Okay, so some of you got the answer. So somebody says I'm not able to add the 3D matrices. I mean, it's just 3 loops, right? We have seen how to do it for matrices. Just think about how you do it for 3D. It is the struggle of programming. It is the struggle of figuring things out. That's how you learn problem solving skills. And this is not just true for programming. This is true for anything. Even when you are solving mathematics problems or physics problems when you are young, right, in your 10th, 11th, 12th class, how do you become better at solving problems? By solving more problems and struggling through it. There are no shortcuts. Okay, let's be realistic there. So try to do this. And if you can't, just Google search for it. It's so simple. You just Google search for it, you'll get an answer, right? But I want you to try it for a few days, struggle with it, because that struggle teaches you how to think in terms of nested loops with three nesting. Addition of 3D matrix is nothing but three for loops instead of 2 for loops that we did for the 2D matrix. It's a very simple concept. Try it. So somebody says, how important is object-oriented programming for a data scientist? Again, the data scientist is a very misused term, because it could mean so many things. So if you're writing production quality code, again, there are some data scientists who also write production quality code. If you're writing production quality code at a large software company, you have to know the basics of object-oriented programming. You don't have to be an expert of object-oriented design. Remember, they're 2 different things. Typically, object-oriented design is something that senior engineers and architects typically write, right? Most data scientists write, maybe just extend a class or write a few functions in a class. So you should know the basics of object-oriented programming. What is a class? What is an object? All of that. Some of which we have discussed yesterday. Some of which we'll discuss in the future live sessions also. But you don't have to be an expert at object-oriented design, like design patterns, etc. Right? That's much more challenging because it requires much more thought process and much more deeper understanding of object-oriented programming. You don't need that for a data scientist. But basic understanding, if you can use basic object-oriented code, if you can read through object-oriented code, if you can use modules, if you can use classes defined by others, I think you're in a good sweet spot. Okay, somebody says, where is yesterday's notes? I think you didn't see the live session. After the live session, there is a video posted on YouTube. Under that, the first comment is the live session. Please go through that, right? Somebody says, please go through 1 case study in the live session. I'm planning to do much more than that, so don't worry. We'll take a new live. We'll hopefully take many more code snippets, both from our codes and outside of our codes, and go through it. Okay, so we'll surely do that. Do we need to be an expert in Python to become an expert in data science? Again, what is an expert? I don't consider myself an expert programmer. Let's be honest there, right? Because I've seen people who are terrific with Python programming. As long as you can write Python basics, as long as you can write decent Python code, working decent reasonably optimal Python code, I think you're good. You don't have to be an expert, because what an expert for you may not be an expert for me, right? So for me, an expert is somebody who knows how the Python interpreter works, the internals of many core libraries of Python, etc. If you can write decent programs in Python, use libraries, and if you know the basic constructs, again, the syllabus that I gave for all these live sessions, right? If you know that, you're in a pretty good spot. So, sounds good. So it's already 6:02, right? So, and anyway, tons of people have already started, so have already joined in. So let me dive into the session itself without any further delay, because I have again 5 problems. This is the agenda for today. So I hope everybody can see my screen. Okay, everybody can see my screen, right? So let's dive into it, right? So we'll come back to questions a little while later. Again, some of these, I try to make the questions today slightly more interactive. I'll keep asking you questions in between and looking for your feedback. I thought I'll make it more two-way rather than just one way, right? So I'm also learning how to do these coding live sessions. Yesterday was one of the first I've done. So I'm learning with you. So first and foremost, live session 2. Today we'll try to solve slightly harder problems than yesterday, but they're no means hard problems. Okay, these are harder than yesterday's sessions, but they're no way, I mean, I don't consider them hard problems, right? These are problems that you will face in interviews, right? So yesterday's focus was simple programs, reading error messages, reading references, and fixing bugs. That was the biggest focus yesterday. Today's focus will be, let's do a little bit of mathematical programming. Again, mathematical programming or numerical programming is a huge area. I've taken semester-long courses where we just talk about numerical methods. Again, where I've both at undergraduate level and at graduate level, I've taken multiple courses for this, right? What I'll try to cover is some basic stuff. Along with it, we will cover some common errors. I'll also teach you how to test your code, how to test that your code is actually working well or not. We'll also focus again on loops and iteration and a little bit about recursion. I'm assuming that all of you know recursion, because I've already mentioned this as a prerequisite, right? In our course videos also, we have shown a lot of sample code, I mean the standard examples for recursion also, right? So the assumption that I'm making here is that you all know Python programming, the basic Python programming. There may be some new concepts in mathematical programming for some of you. I'll introduce the new concepts as we go. So don't worry about it. Don't panic that there's going to be too much mathematics. I'll explain the mathematics simply for you. Once I explain the mathematics, we'll go into programming, right? So we'll do mathematical understanding and programming parallelly now, right? I thought this is a great way to build the mathematical intuition, because most of machine learning AI requires programming or mathematical programming. So I thought let's do 4 or 5 problems just on mathematical methods, or it's also called as numerical methods. So again, I remember I studied this when I was in BTech first year. Again, computer science students, non-computer science students like electrical engineering, even civil engineering folks learned a little bit of numerical methods. I think it's also there in their GATE syllabus if I'm not wrong. So I'm assuming whatever your engineering background is, you must have studied some numerical methods. But even if you don't know these numerical methods, don't worry. I'll introduce these new concepts. I'll explain them to you with simple diagrams so that you can follow what I'm trying to convey, right? Very importantly, some of these questions and their variations I have actually asked in actual interviews. Again, these are not hard problems. These are simple problems. I've asked some of these questions as interview questions in my prior experience at top product-based companies. Some of these problems would be like the first interview question that I would ask, especially if somebody comes from machine learning background or anything like that. Again, these are not the exact problems that I've asked, but very similar problems and simple variations to these problems are what I asked in actual interviews at companies like Amazon, right? And these are simple problems. These are no way the hard problems that you might be asked. Okay, first and foremost, I just wanted to make sure that we are using Python 3 and not Python 2 this time. We know how to do it. We saw this code snippet yesterday. Just import system, print system.version. My version is 3.7. Just wanted to make sure that we are not in Python 2, right? So I'll try to do most of these sessions. I think yesterday's whole notebook was Python 2.7 and not Python 3.7, right? So from now, I'll try to use as much of Python 3 as possible. Okay, let's go to the first problem now, right? So first problem is this. Okay, so I don't want to show you the solution right away. The first problem is this. The first problem is finding peaks or maximum values in a list. Now, what does this mean? Let me explain this. Look at this. Look at these lists. This is a list, right? Remember that this is just a list of numbers. Given a list of numbers, I want to find peaks here. What do I mean by peak? If I try to plot these values, look at this. If I try to plot them, so let's assume this is my x-axis, this is my y-axis. My x-axis is the index in this list. My y-axis is these values. The first value is 1. So first value is here. First value is 1. The second value, this is the first value. The second value is 3. So it will be here, right? The next value is 4. The next value is 5. The next value is 7, right? So on and so forth. So if you just plot these values like this, if you plot these values, you'll get some pattern. Now I want you to find the peaks in this pattern. So if you look at this, what are the peaks here? Look at this, 7 is a peak. If I try to plot all these values in y-axis with their indices on the x-axis, 7 will be a peak, because till 7 it's all increasing and after 7 it is decreasing, right? That's very clear, right? Similarly, is there another peak? Yes, 10 is another peak, because all the values just before 10, look at this, you compare it with the values before this, it is increasing. After that, this is a dip here. So if you actually plot these values, you will see a peak at 7 and you will see a peak at 10. Right? Very simple. I hope the question is simple. Right? Now, again, this is a very simple problem. Should be extremely easy to understand. Now, what is the logic? Okay, I'll tell you the logic. I'll ask you a follow-up question later. Okay. So the logic is very simple. What are the peaks here? The peak is 7 and 10. So given a list like this, I want you to print these peak values, also called max values. Again, these are not the largest values. Unfortunately, these are actually the largest values. But what I mean by max here is peaks here. So if I try to plot this data, it will go up. At 7, I'll see a peak, again it will fall. Again at 10, I'll see a peak, again it will fall. So these two peaks, 7 and 10, is what I want you to print. Now, how do you come up with the logic? Right? It's actually very simple. If you think about it, if you compare this 7 with the number just before this and just after this, look at just the number right before this and right after this. Right? This 7 is larger than 5. This 7 is also larger than 6, which means this must be a peak. Again, this is called as a local peak, because if you look at it, it looks like this. This pattern, if you plot it, this will look like this. So this 7 is greater than its previous number, which is 5. It is also greater than its next number, which is 6. Now, on the other hand, you have 10 here, you have 5 here, and you have 1 here. Similarly, if you look at this 10 is larger than your 5, and it's also larger than 1. That's why it's a peak. Now, let's look at another number. Look at a number like this. This is not a peak, because while this is greater than 4, this is not greater than 10. So this is not a peak, right? A very simple way to detect peaks is just compare every number, pick every number, start with this number, pick every number with the two surrounding numbers that it has. Very simple concept, very simple logic, right? The logic is straightforward. So what is the logic here? Again, the logic, once you get the logic, you'll have to translate that into coding concepts. What do you have to do? You have to first go through each of these elements, which means you need a for loop. Look at this. You have to iterate through each of these values, which means you need a for loop. First thing, you need a for loop. Cool. And then when you iterate through each of these loops, pick any element, compare this with the previous element and the next element. Right? So let's assume the variable in your for loop is I. Right? Then what you have to do? You have to compare if ai minus 1 is less than equal to ai, and if ai is greater than equal to ai plus 1, then print ai. That's all is the logic. It's a simple for loop, right? And a simple if-else condition, if condition. If these two conditions, if this condition is satisfied and if this condition is satisfied, you get it. Again, I have not written any code yet. I have not written any code. I just got the logic and I connected the logic to two concepts. Simple for loop and if-else conditions. Now I'll start implementing it. That's where things, again, we got the logic, always first get the logic. Very important, with some simple examples like this. Then connect to concepts, connect to programming concepts. What concepts in programming should you use here? Then start writing your code. Start code. These are the 3 steps. Of course, you should then test the code, all of those stuff. Right? We'll come to that. Okay. I'll teach you more interesting things today. Now, the first thing, let's assume I start writing the code. When I start writing the code, look at this. For I in, what should be the range of I? Okay. What should I go through? If I starts here, I can compare it with this, but I can't compare it with any number here. Right? There is no number here. Similarly, this number, I can always compare it with this, but I can't compare it with the number after this. Right? So what should I do? My I should start from this index to this index. What is this index? This index is 1. Right? This is index 0, this is index 1. So what did I say? For I in range 1 comma a of size minus 1. Right? A of size minus 1. Remember, this 1 and minus 1 are important here. Again, this is what happens when you translate the concept. I told you, right? So we got the concepts clear. Once you got the concepts, you have to translate very carefully to code. You have to think about what happens for this. You have to think about what happens for this. The translation you have to be very careful with, right? So I translate the code and I get an error. Very simple error. Okay. I think all of you can see the error here, right? I wrote this code. The code sounds correct. For I in 1 to a size minus 1, which means from this element to this element, if ai is greater than equal to ai minus 1 and if ai is greater than equal to ai plus 1, print ai. It's a for loop with a simple if condition with 2 conditions that I have to check. Both these conditions must be true. That's why I have logical and here. Very simple logic, right? The moment I execute it, I get an error. I want you guys to tell me what is the error here. The error says list object has no attribute size. Look at this. It says list object has no attribute size. I want you to tell me what is the error. Please look at this code. List, again, which line does it say it has an error? It has an error in this line. Look at this line. It says the error is in this line and it's an attribute error. The list object has no attribute size. Now I want to hear what your interpretation is. We have discussed this yesterday, right? So let me go to the live and see. Oh, somebody said very nicely. Yes, we should use length instead of the size of the list. Right? Very good. Thank you. Very good. So what does it say? What does this error message clearly tell us? This error message says, see, A is a list here. What is a list in this line? In this line, A is the only list. A list does not have an attribute size. I'm trying to call an attribute size which does not exist. Right? Because I'm using the notation for NumPy and the arrays. NumPy and the arrays has size. List does not have size. So what is the right thing to use? Len. If you want the length of a list like this, again, this is a very common mistake that we see. People thinking that they're used to using NumPy arrays, right? So they're used to using size. So they'll use it even on lists. And that's a very common error. So what we should use is not size, but to get the length of a list, we have to use the len function. So first try that, right? Again, if you're not sure, just Google search for it. Just Google search. It's actually length of a list. If you just Google search for it, I should say Python. I should just say Python. Okay. Length of a list, Python. The len method is most commonly used to find the length of a list. That's it. Geeks were there are tons of resources online. Google gives you an automatic answer also. So now I say, let me just check. Print length of a, it gives me 10. There are 10 elements here. Perfect. Very good. Now I modify my solution, right? Look at this. I simply modify it and say, instead of a dot size, I'm using length of a. Cool. It's giving me 7 and 10 as I expect. Cool. This is very good. Things are working. Are we done? My big question to all of you is this code correct? Is this code correct? Okay, I would like to see what you guys think. Is there a bug in the solution? Is there a problem with this solution here anywhere? Is there a problem? Do you think there is a problem? Let me hear you guys. Okay, somebody says use blah 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 length of a, yeah, I got it. Okay. So good. Somebody got a good question. What if the peak is in the first position or the last position? Thank you, Joel. Very good point. So what if? That's a very good point, right? So this is called as boundary cases. When you write your code, I told you, right? I'll teach you how to also test your code, how to find common errors, logical errors. Here what we have is not a syntactical error. What we have is a logical bug. Look at this. The bug is as follows. What if, what if my first element is a peak? If you plot this, 11 is the largest, then it falls. So this is 11. This is 11. And then 3, 4, 5, 6, 3, 4, 5. And then it again raises to 7. 7 is the next peak. Then you have 6, 5, 4. Then you have 10. Then you have 10. Then you have 10 and then 15. So what are the peaks here? They should be 11, 7 and 15. Right? Now there is a peak here, there is a peak here and there is a peak here. So what if your first element here is larger than the element that is right next to it? In the previous loop, we skipped the first element altogether. In the previous loop, again, that's a bug, that's an error. In this logic, right? In this logic, we skipped the first one. We skipped index 0 and we skipped the last element because I have a dot size minus 1 here. Right? That's a bug. That's a logical bug. So now how do you fix that bug? So for example, on this array, there's a bug. Very good. I'm glad you guys found that bug. Again, these are logical bugs. These are not syntactical bugs. Right? If I execute this using the same code that I used earlier, I get only 7. Look at this. My output is only 7. But I actually want to get both 11 and 15 also. So what about 11 and 15? These are called as boundary cases. Okay, whenever you're writing code, you should ask yourself what happens in the extreme cases. What if my peak is in the leftmost corner or the rightmost corner? That's like the extreme cases, right? Or the boundary cases. Please don't miss them. And in interviews, when people ask you simple questions, their objective is to ensure that you're handling the boundary cases well. Right? If you don't handle the boundary cases, that tells the interviewer that you're not thorough. You're writing some code, you know what is a for loop, you know what is a if else condition, but your code cannot be productionized because these boundary cases can kill code and software. So what interviewers want to see is that you're writing the simple for loop with if condition, all that, but you're also handling the boundary cases gracefully. So there are 2 boundary cases here and we'll handle them very easily. The boundary cases are simple. If A0 is greater than or equal to A1, print A0. The rest of the loop stays the same. This loop stays the same. This is comparing from the first element to the last but one element. This is the first element. This is checking for the last element. That's it. I get my answer. Very simple. Very, very simple code. Nothing fancy, nothing complex. So the most important lesson for you is please don't forget boundary cases. If you forget boundary cases, an interviewer can say you're either reckless or you're not thorough. I've been in interview loops where people got rejected because they did not handle boundary cases carefully. It's a very important basic condition. Again, most people don't think that this is important, but when you write production quality software, boundary cases are the matter of life and death sometimes. I mean, I've seen cases where the whole servers can come down because of a small mistake. I've seen cases where somebody did not handle division by 0 and it can crash machine learning models. I've seen such cases, right? So we have to be very, very careful. Next, what is the time complexity of this? Should be trivial for you to answer, right? Any suggestions? Oh, actually I already gave this whole sheet earlier, right? That's why the answers are faster today. Yesterday I didn't see the answers. To be this fast and this accurate. Actually, this problem and even the next problem I think I gave. In the yesterday's sheet itself I gave. Okay, so let's clear these 2 questions fast. Third question say we'll start the real fun. Okay, so what is the time complexity? Everybody is very quick. They're answering order of n. I'm happy you thought about it. Again, all those people who have gone through the sheet with this question and the next question yesterday, I'm happy about it. I'm happy that you put extra time. Also, if you have time, please do the exercise problems. Now, my exercise for this is simple. Okay, there are 2 exercise problems here. Very simple. Find peaks which are max values in a window of 2. What I mean by this is, imagine if you have a list like this. right? Imagine if you have a list like this. For this array, for this element, like for example, okay, for this element to be max, okay, so what did we do now? We only compared with the value to the left of it and to the right of it, which means we only compared one cell to the left, one cell to the right. Now what I'm saying here is compare two cells to the left. What I'm suggesting now is instead of just comparing one cell, please compare, okay, so let me just draw this carefully back. Okay, I'm saying compare this with this and this, the two cells here. Similarly, compare this with this and compare this with this. If this is the maximum amongst these five, if this is the maximum amongst these five. So when I say window of size 2 on both sides, two elements here and two elements here, right? This is called the window of size 2, window of size 2. If 8 is larger than all these, 8 is the largest element amongst these 5 cells, then print 8 or else don't print 8. Simple? Very simple, right? So imagine if my array, or sorry, this is not an array, right? This is a list. Imagine if my list consists of n elements. Imagine if my list consists of n elements and if my window size, right? If my window size is w, right? Window size is w on both sides, right? On the left side, I'll compare with w entries given a cell or given a value. On the right also, I'll compare with w cells here. And if this value is the max amongst these 2w plus 1, only then I print it. Now, I want you to implement it. It's not hard. Also, when you implement it, think about the time complexity. Think about the time complexity. Okay, think about the time complexity. Just think about it. If you implement it very easily, okay, let's ask this question, right? Imagine if I have n elements and if my window width is w, what is the time complexity enough? If you implement this using simple two for loops, one for loop will go through each of the n elements. The inner for loop will go through this window of elements, w on the left, w on the right, right? It's a simple two for loop. Now, what is the time complexity of this, of such a solution? Any ideas? Okay, order of n into w. Good. Very good. Yes, it's order of n into w. Because your outer loop here is iterating over n values. Your inner loop here is iterating over 2w values. So how many times this line will get executed? The inner loop lines, this inner loop line will get executed n into 2w times. So again, order of n into 2w, you can always remove constants when you're talking about time complexity. It is order of nw. Very simple. Now, this is good. Now you might, if you Google search for it, if you Google search and say find peaks, right? Find peaks in list, let's say, Python, I should say Python, sorry. I should say Python. Okay, the first link that you get is in SciPy, there is a function called find peaks, right? So I want you to solve this problem using two ways. One, you implement it yourself. The second, if you want, the second thing that I want you to do is to use this scipy.find.peaks. I want you to read through this documentation. Look at what are the input arguments or parameters. Look at each of these parameters in SciPy. I want you to read this and implement the problem in one using scipy.signal.findPeaks. The first one will teach you how to actually write for loops gracefully. The second one will teach you to read the documentation and use functions, right? Those are the two ones. Again, those of you who want to learn more efficient algorithms for this, there is a divide and conquer approach to solving this. Again, there is a very nice lecture notes from Eric Demain at MIT. Again, this is the best book that I know of for algorithms. When I taught algorithms for interview preparation and also for GATE, this is the book that I referred. So Eric Demain has this, again, he goes over it. He explains, again, this lecture notes is terrific. Those, especially computer science students who want to learn more efficient ways of doing it. There is a whole, I think this is a 1.5 hour lecture. This is a whole lecture called peak finding. It's a 1.5 hour lecture where at MIT, that too, right? Where they explain how to do peak finding more efficiently. People who are interested in better algorithms can always refer to this, right? Cool. Okay. So let's go to the next problem. This problem is simple. We got through it. So please try to solve these exercises because that's how you become better at it. Okay. Somebody is asking about notes. Again, I'll put the notebook at the end of the comment section always, right? So don't worry about it. Even yesterday's live session, in the very first comment is the IPython notebook link. I'll put both the PDF version and the IPNB version so that you can execute this, modify this, play with it, or just read it when you're sitting at home, right? Okay, so next problem. This is a very, very popular program in most interviews, especially if you're a computer science student. People expect you to write this code. Very simple code. Now the problem here is very interesting. Okay, we'll solve it in two ways. Okay, the first way here is, imagine I'm given a list like this, LST, which is 1, 2, 3, 3 elements. It's a list of 3 elements. I want to write all permutations. You might have learnt about permutations and combinations in your 10th class or 11th class or 12th class. You remember N, P, R, all this you must have learnt. Again, I'm not assuming that you remember the formula for this. You don't have to. Don't worry about it. What does permutations mean? For those of you who have forgotten it. Permutations basically means reorderings. In how many ways can I reorder this? I can write it as 1, 2, 3. This is one ordering. The other ordering is 1, 3, 2. The other ordering is 2, 1, 3, 2, 3, 1. There are many such orderings, right? So the problem that we have here is, given a list like this, I want you to print all the orderings. Now there is an easy way. If you just Google search for it. If you just Google and say permutations, okay, let me show you that, right? Permutations Python. Okay, there are a bunch of links. Okay, you can get lots of links. Okay, let's go to the first link itself. I've gone through many of them. Okay, in the first link they say, okay, here is a code. You don't have to write any code, right? There is actually a toolbox. Very simple. Again, you can read about the documentation and all that. I'll refer here. I just Google search for it and I found this link. The moment you find this link, the first thing that you have to do is you have to read through. If you don't know ITER tools, if you don't know this module called permutations, read about it. Here I've put the documentation. Please read the documentation. In the interest of time and in the interest of moving forward to other problems, I'm not doing it. I've done it yesterday, right? So please read through the documentation. Okay, actually let's read it. Come on, why not do it? Because I don't want students to take shortcuts and not learn the foundations. Okay, so what does it say? Okay, let's read the documentation, right? It shouldn't be hard. Okay, itertools.permutations. It says the input has to be iterable. What does iterable mean? Let's understand that. R is none. Okay, returns successive R length permutations of elements in iterable. Now, if you don't know what is iterable, some of you may not know what is iterable, right? So what is an iterable in Python? Just Google search for it. This is one of the links that you will get. Just read what is it if you don't know what is an iterable. Okay, very nice documentation. An iterable is a Python object capable of returning its members one at a time, permitting it to be iterated over in a for loop. Right? Very simple. And it clearly says, okay, functions that act on iterables. So look at this. Your list, tuple, dictionary, set. Right? All of them are iterables here. Right? All of these are iterables. Right? Very simple. You just Google search for it. Now you understood what is an iterable. Right? So I can pass a list here. Look at this. Because a list is an iterable object, I can pass a list here. So what is R here? If R is not specified or R is none, then R defaults to length of iterable and all possible full length permutations are generated. What we want is full length permutations, right? I want all the permutations of 1, 2, 3. I don't want permutations of length 2 or anything. There are three elements here in this list. I want all the 3 permutations. So what do? I know how to call these permutations. I just, from ITER tools import permutations, I say P equals to permutations 1, 2, 3. Because I can pass any iterable object is okay. This is a list and a list is iterable. We know that, right? Now, what does it output? That's also important. Let's read it. Okay. So permutations are emitted in lexicographic sort order. One second. Returns successive R-length permutations of elements in an iterable. It will result in another iterable. Look at this. It will return another iterable object. What is iterable? I can put it in a for loop, right? Anything that I can iterate over in a for loop is iterable, right? So what can I do here? I got P. So what am I doing here? I'm saying for I in, I'm converting this P into a list. Look at this. I'm converting this P into a list. And for I in list P, I'm doing print I. That's it. I get all of my iterations. Look at this. All these are in lexicographic order because 1 is smaller than 2, 2 is smaller than 3. This is in sorted order. Similarly, 2 is smaller than 3. See, if the first digit is the same, the second digit is sorted is sorted in the same order. Look at this, right? If the first element is the same, the second one is in the sorted or lexicographic order here, right? So that's important. Very simple code. So what did we learn here? We learned that permutations can be done using libraries. We learned what is an iterable object, right? And we just saw how to do it. Why not? I just have a small curiosity because what P is returning. Okay, let's try to figure it. I have not tried it, by the way. I have not tried it yet because it says it returns successive R-length permutations in iterable. Anyway, it's returning it in iterable. Why should I convert it to a list? What if I just say for I in P? Look at this. Because P is iterable, for I in P should give each of these elements of P to me back. So what happens if I run this? Oh, it works. I don't have to convert it to list. It works. Look at this. What did I do here? Earlier I said a list. I converted it into a list, right? Earlier. I don't have to because P itself is iterable. Because P is iterable, I can write a line like this. What it will do is for each of these loops, it will pick I will be assigned one of the values in this iterable object. I don't have to care about the data type here. Because it is iterable, I can use it in a for loop like this. That's all matters. That's it, it works. Actually, I haven't tried it earlier. Right? So cool. So this is working. But this is no fun. Right? You just used some library. Again, in an interview, if you use this, the interviewer will immediately say, sorry, I want you to implement it from scratch without using any library functions. I mean, I've done this, by the way. I have seen some people who say, hey, there must be some inbuilt function. I'll just call it blah, blah, blah. I say, sorry, you have to implement using first principles. You have to implement using basic concepts of Python. Now, these are the outputs that we want, right? Now, how do we write our own code? Any suggestions? Right. Again, this problem we already listed yesterday. So let me see. Oh, somebody is saying time complexity. People have gone to time complexity, space complexity also. Oh, okay, fine. Again, I want this to be more interactive as we go. That's why I don't give the questions the previous day, just in the interest of the discussion and people who might be slightly on the slower side of grasping. But anyway, that's okay. That's okay. Let's finish this. Okay, so you can solve this. Again, the way to break this is, okay, from tomorrow I'll not give the unsolved problems of today. I'll not put it in the code so that we'll have much more fun. Okay. So somebody is saying nested loop. Yes, you can do it using loops also. It's not easy or trivial, but you can do it. There are many ways of solving this problem. I mean, there are non-optimal ways, there are optimal ways, all of that. What I'll try to explain now is, I'll try to explain a way which is intuitive, right? Not optimal, but intuitive. There are many optimal ways of doing it. Again, if you just Google search for this, you'll get like tons of solutions. Look at this, permutations, okay? This is one solution. Again, there are many other solutions, okay? Iter tools, combinations, blah, blah, blah. I'm sure people would, okay. So, okay, without permutations, Python, using recursion. If you just type this, you'll get tons of solutions, by the way. Okay, this is one solution. I actually read this solution also. There are many ways of writing the code for this, right? So let's pick again, what I've listed here. I've taken this code from Stack Overflow. This is one of the easier to understand codes, right? Because the core idea here is to get the intuition. We can do code optimization also. We'll do it later. Okay. First and foremost, let's see how, if I have to write all the orderings, how do we write? Right? Let's think about it. First, I'll use 1. With 1, so first I fix my first position. Then I get 2 and 3. In how many ways can I arrange 2 and 3? I can do 2 and 3. I can also do 3 and 2. Right? This is one way. Next, I'll take the second element. If the second element is here, what are the elements are not here? Because I fixed 2 here. So I'm left with 1 and 3. So I'll try to arrange 1 and 3. 1 and 3 can be arranged in 2 ways. Right? Next, I'll fix 3 here. Once I fix 3, I'm left with 1 and 2. I'll arrange 1 and 2 this way. This is how we have done it when we were in school and things like that, right? Very simple way. So first element you fix. Okay, see, I want 3 element permutations. So a permutation of 3 elements. First, I fix the first element. Then I'm creating permutations of size 2. Look at this. To compute permutations of size 3, I fix, see, what am I doing here? Look at the logic here. The logic is the important part. Again, some of the most interesting interview problems, both for computer science students, even for software engineers, are all based on recursion. Recursion is the most beautiful concept in whole of programming. Like some people might say dynamic programming, right? Again, those of you who are from computer science background, who have studied data structures algorithms, most dynamic programming algorithms are nothing but recursion plus some memoization or storing some data. That's what it is. Most dynamic programming is simply recursion plus storing some data. Again, we discuss this. We discuss about how recursion and memoization, how dynamic programming works in our AI course when we learn about backpropagation. When we learn about backpropagation algorithm in deep learning, I discuss about how backpropagation algorithm is also nothing but recursion with memorizing some values or storing some temporary values, right? The so-called DP, dynamic program, some of the hardest problems in some of the hardest interviews are dynamic programming problems. Not for machine learning, for even software engineers. But all of those problems break down into recursion problems. If you understand recursion, if you can solve recursion problems, you can crack any damn software engineering interview. Trust me. At least most of them, if not all of them. Right? So, okay, back to this discussion. Sorry, where were we? Okay, we were here, right? So what is our logic here? Let's understand the logic. So in the first element, I'm placing all the elements that are there. First, I place the first element. Then I place the second element. Then I place the third element. Once I place the first element, again, to get orderings or permutations of size 3, first I fix the element. Then I'm looking for all the orderings or permutations of size 2. So look at this. If I want permutations of size 3, what do? I fix the first element. This first element. Okay, this first element can be any of these values. Then the second and third element, to get the second and third elements, I'm just using all the other permutations of size 2. So a problem of larger size can be broken into same problem of smaller size. Look at the logic here. That's the important part. For factorial also, an n factorial can be represented as n into n minus 1 factorial. So a problem of larger size can be broken up into smaller problems of the same type. Then you can apply recursion. In permutation also, a permutation of 3 elements can be broken down into iterating through all these elements, first element, second element, third element. So what do you need? For this. To get this, you need a for loop. Why do you need a for loop here to get the first element? Because you have to first use the first element, then the second element, then the third element. When you fix the first element, look at this, you need a for loop. When you fix the first element, then you will call this permutation function again with 2 elements so suppose if you put 2 here, the leftover elements are 1 and 3. So you call this permutation with these elements 1 and 3 and you get 1, 3 and 3, 1, 2 possibilities and you print all of them. Recursion is one of the greatest ideas I think in whole of computing. I mean, If I have to pick one idea in programming that I love the most, it is recursion, hands down. Okay. So we got the idea. Now, how do we translate into code? Again, this is not the most optimal code. I'm making it very clear here, but it is the easiest to understand. Okay, let's look at this. We are creating a function called permutation. Again, I've borrowed this from a Stack Overflow post, very well written post, right? So again, it's very important to clearly state where you're getting your material from. Again, when you write your own notes or anything like that, if you're using an external source, please credit them. It's it's a scientific practice we have been using for the last 400, 500 years. Even prior to that. Even if you look at old mathematical text from China and India, people say so-and-so person said this, which I'm using, right? So it's important. Okay, sounds good. So let's get back to our discussion now, okay? So I'm defining a permutation. So this whole thing is my function called permutation, right? And my input that I want to give to this is the list. Okay, I want a list. I want it to be able to take a list. Say again, in recursion, as we discussed in our course videos, in recursion, there are two parts. There is something called as a base case and there is a recursive case. Base case basically means, what is a boundary case? For example, for n factorial, right? The base case is 1 factorial equals to 1. Beyond that, you can't break this down into smaller parts. That's why it's called the base case, very importantly, right? So what is the base case for our permutations? If the length of S is 1, if I just get a one element, just a list with only one element, then there is nothing to permute. There is only one way in which you can do it. So just return that. You're done. Right? So this is called as the base case or the boundary case. This is called the base case of recursion. Right? I think all of you know the n factorial thing. That's why I'm trying to connect this. So n factorial is n into n minus 1 factorial. But the base case is 1 factorial equals to 1. So in the recursive function for n factorial, you will say if n equals to 1, return 1. Same thing. Here the base case is if the length is 1. You should always handle this. Next, okay. My resulting list, the list that I want to output, I'm initializing it to an empty list. Again, we discussed it yesterday, right? It's always a good habit to create variables that you want to use. I'm just creating an empty list here, right? I didn't even change the variable names because I want to use the code as is, right? Then it says, look at this. What was our logic? If you recall the logic that I explained a while ago, there are two parts to it, right? The first part, I need to iterate through first element, second element, third element, which means I need a for loop here. Within the for loop, I need look at this, within the for loop, okay, let me change the color here. Within the for loop, I need a recursion. So given that I've understood the problem, I've also connected it to the concepts. I have to use recursion. Within the recursion, the way it will work is I'll have a for loop. Within this for loop, there will be a recursion. That's the trick part. Most recursions of simple problems like n factorial, the recursion is not inside the for loop. Here it will be inside the for loop. For A in S, you gave me S, right? So let's assume S equals to 1, 2, 3. You gave me A equals to, let's assume it contains 3 elements. So this condition is not true. My output list, right, is empty for A in S, which means first I'll pick this, then I'll pick this, then I'll pick this. The for loop concept, right? Look at this. There are 3 cells. The first cell, I need a for loop. For this, I need recursion. So for the first one, this for loop corresponds to, first I'll pick 1. So A will be 1 first. So A will be 1. Right? Next, once A is 1, I want a list of all the remaining elements. My remaining elements are, look at this, I want the remaining elements. Remaining elements are 2 and 3. So how am I writing this? I'm writing it a one-liner. I'm saying x for x in S if x not equals to A. Look at this, x. I want all the x such that for x in S, if x is not equals to A. So take each of these elements. What is A? A equals to 1 now, right? Anything that is not equals to 1, give me those values. So what will these remaining elements be? These remaining elements is 2, 3. Again, this is a concise way of writing. If you're not comfortable in writing the concise way, you can write a simple for loop and get the remaining elements. That's okay. Again, as I told you, I've just copy pasted this code here. I've not modified it even a single bit, right? So This is a concise way of writing it. So when you encounter, again, you may not write code like this, but if others have written code like this is very simple to read. X, you want all the x's such that for x in S, if x is not equals to A, that's it. Very simple to read if you think about it. So this remaining elements will contain 2, 3. Now, I want all permutations of remaining elements. My remaining elements is this list 2, 3. My permutation function, again, I'm calling permutation within permutation. So what should this return? This will return some Z. This Z should be list of all permutations of 2, 3. So it should be 2, 3 and 3, 2. That's how we'll write code, right? Next, look at this. So here, let's say I fixed 1. Okay. So how is the code working? This is important. So here I'm writing 1. I got these 2. The Z now contains these 2, right? Z is a list of lists actually. Z is a list of lists. Very simple. Now what do I do? For T in Z, for each of these, append each of this to 1. So for T in Z, permlist.append A plus T. When you do A plus T, what happens? This A, which is 1, gets appended to 2, 3. This whole entry now, 1, 2, 3. This list gets added to my perm list. Cool. Next, for T in Z, right? So next 3, 2. Then I'll get 1, 3, 2. So now my perm list will contain 1, 2, 3, 1, 3, 2 by the end of this loop. But this is not over because this for loop, it started off with A equals to 1, but it will continue with A equals to 2 and A equals to 3. So by the end of this whole thing, by the end of this whole function, my perm list will contain all the possible permutations. And I just print it. Look at this. Look at what I get. I get 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Right? Very simple. Again, the challenge here, the reason why most people make a mistake here, okay, very importantly is people have seen n factorial, Fibonacci, all those toy examples. The important aspect in that is it's a very straightforward recursion. Here you have a for loop and a recursion within the for loop. This is the trickier type of recursions. If you can handle this, again, this is a very, very common interview question. I've seen a lot of people ask this. And again, it is simple. If you know the concept, it is simple. Again, what is the time complexity of this code? Look at this. So, okay, let's write it down. Okay. Again, there is a whole lot of mathematics on computing it, but how many, look at it very simply, right? How many permutations do we have? Okay, you have 3 elements. So let's say you might have n elements. How many permutations you have? If you have n elements, in the first place, you can place any of the n values. In the second place, you can place any of the n minus 1 values. In the third place, you can place any of the n minus 2 values. In the fourth place, any of the n minus 3. In the last place, 1 value. So how many permutations exist? N factorial permutations. So even if you write a very, very optimal code, your number of permutations will always be order of n factorial. And n factorial is is large. Okay, n factorial is quite large, right? So I hope you got the concept here, right? The exercise problem, what I want you to do here is this. Okay, this is actually a lot of fun. Okay, so with this, we'll finish the 2 problems that we discussed yesterday and we'll start the new problems of today. I don't know how many we can finish. But anyway, whatever I can't finish, we'll carry them on to tomorrow. Okay, but I want to explain it thoroughly so that everybody benefits. I hope the concept here is clear, right? So first, let me explain the exercise. Then if there is any question, I'll take it. Now I want you to print combinations just like permutations. So imagine if I have 5 elements, let's assume I have 5 elements, 1, 2, 3, 4, 5. I want combinations of 3 elements. What is a combination? Or I want all the possible ways to pick 3 elements from 5 elements. Right? How do you do that? Look at this. How do you do that? If you think about it, let's think logically, right? So let's assume C of, let's say 5 elements, C of 5 elements, right? So again, first thing that should strike you is, maybe I can write it with for loops. If I can't write it with for loops, maybe recursion is the solution, right? Always think, don't forget recursion. Many people just still think in for loops, They don't think of recursion, especially non-CS students. Okay, so let's look at this. I have 5 elements here. I want to pick 3 elements, right? So I have 3 places. In this first, again, the order doesn't matter now. The order doesn't matter. In combinations, I'm saying how many ways you can pick 3 elements. So here 1, 2, 3 is same as 2, 3, 1, because the order doesn't matter in combinations. I just want to know in how many ways can I pick 3 elements from these 5 elements. That's all I care about. Okay, so let's see. First, let's assume I pick the first element. Okay, first I pick the first element. I pick 1 element. Then I have to pick 2 more elements. See, at the end of the day, I have to pick 3 elements. Think how we will write all the possibilities. First, I'll pick this element. Okay, let's try to think how we will solve it. Forget about recursion now for the time being. First, I'll pick 1, right? Since 1 is there, I have 2 more places that I can fix, right? So I've picked 1. Now I look for other ways in which I can pick 2 elements from these 4 elements. Look at this. What do I want? The recursion is, or okay, let's forget recursion. Okay. First I picked 1 element. Now there are 2 more elements that I want to pick. So I want to pick these 2 elements from these 4 elements. Okay, that's one way. Okay. Now look at this. The order doesn't matter. So can you solve this problem as follows? The number of combinations of picking from 5 elements, right? And I want to pick 3 elements from, okay, let me write it this way instead of writing it this way. I want to pick the number of combinations in which I can pick 3 elements from 5 elements is pick the first element and think of how you will pick the 2 elements from the 4 elements. So first pick an element, then can I somehow break it? I'm not telling you the solution. I'm just giving you a hint here, right? Again, you have to work out the logic yourself, but I'm just giving you an intuition here. The number of combinations of picking 3 elements in 5 elements, 3 out of 5 is pick 1 element. So pick 1. So let me write it down. Pick 1 element plus, then you have to recurse. Pick 2 elements from 4 elements. But remember, don't make the mistake, because if you do this, there's a very common mistake that people do in combinatorics. Let me also tell you that so that you don't make that mistake. Very common mistake that people do is they pick 1 here. Let's assume they pick 2, 3 here. Now, when they pick 2 here, they'll pick 1, 3 here, and they'll count this as two different combinatorics or 2 different ways of picking. Well, this is the same. This is literally the same because order doesn't matter. So the way to think about it is, can you pick 1 element and then recurse? But make sure that you respect the fact that the ordering doesn't matter, right? That's one. Again, I want you to think about it. Again, you will easily get a solution. If you just Google search for it, there are hundreds of blogs that will give you an answer to this. But again, this problem is not trivial, but think about it, give it a couple of days of hard thinking. If you cannot crack it, then see the solution. Google search for it, you'll get a solution. Trust me. The other option, I also want you to solve this problem using inbuilt functions. Suppose if you type combinations in Python, just type this on Google. Okay, you get this. Okay, so we have already seen the permutations code. Now there is also a combinations code. This is also permutations. Okay, this is the combinations code. So from iter tools, import combinations. Simple. Then you can say combinations blah blah blah. That's it. Just like the way we did permutations, this is pick 2 elements from this list of 3 elements. Okay, so that's what this function does. So this gives you all the ways in which you can pick 2 elements from this list of 3 elements. You just print it, right? So the second part is trivial. But again, what I want you to do is, I want you to go read the documentation. So for example, iter tools combinations, right? Please read that. iter tools combinations. Okay, that's a HackerRank. HackerRank is also another. Okay, they have the documentation. Cool. So they tell you iter tools.combinations. The first thing has to be iterable. The R is the length of the subsequences. Simple. They give you very nice code also, code snippets, so that you can understand what's happening. Just like the previous one, the first one is iterable, which means we can use a list. But it's better to read the official documentation. I prefer the official documentation. combinations. Okay, the combinations is here. Yes. Iter tools and R, it will give you, again, it tells you what it returns. It tells you what it does. There's also a simple code snippet that you can read through. I always prefer the official documentation because it is the most exhaustive. It is the most concrete, no errors, all of that stuff. Mostly no errors, right? So I want you to solve this problem both using iter tools combinations and using recursion. Again, please understand that combinations is slightly harder than permutations, but try it for a couple of days. I really want you to try it. Okay, let's look at the somebody says, I don't know what is recursion. That's okay. Again, you can just Google search for it. Recursion is one of the, again, the prerequisites that I mentioned at the announcement video is that you know the basics of Python. If you don't know, again, there are lots of resources. You can just go to YouTube and just type recursion in Python. You'll get tons of links, I'm sure. Recursion in Python. Right, so there are tons of tutorials. You can just go through any of these. There are tons of resources, some good, some not so good. Just go through it. It should be a very simple concept, right? There are tons of resources for sure. So, okay, sounds good. Oh, somebody says if you can break it the way we save it. Yeah, there is an other implementation of it, right? Which is if you don't want to use recursion, computer science folks would know it. You can actually use a stack and do it, right? But I'm not going into it. Okay, sounds good. So let's continue. Now, recursion is something that I wanted to touch upon. Hopefully, we'll solve some more problems in the future sessions. But here comes the third problem that I want you to think of. How do I? Okay, I hope everybody can see. I don't want to scroll too much down. I want you to think about it. I hope everybody can see this, right? The problem is simple. Let me explain the problem. Okay. Again, this requires only high school mathematics, nothing more. Trust me. Okay. You have an equation like this. Sin x equals to cos x. Let's just remember that all x's are in radians, not in degrees, right? Because radians is the scientific notation that everybody uses. Now, I want to find an x. Think, if you remember, we had quadratic equations, if you remember, like 2x square plus 3x plus 4 equals to 0. Find x, right? If you recall. And we would use this Sridharacharya's formula, minus b plus or minus blah, blah, blah. That formula, that's called the Sridharacharya's formula. And we would get the answer. Now, my question is slightly more interesting. My question here is, given this equation, I want you to find the value of x which satisfies sin x equals to cos x. Can we do it? Very simple. I'm assuming this high school math, right? I want you to find a value of x, again in radians, not in degrees. I only care about radians because that's scientific notation. That's a more scientifically used, that's a more scientifically widely used metric name. What is it called? Unit for this and not degrees, right? Sin x equals to cos x. Find. There could be many such x's. We don't know. Let's find one such x. That's a target. First thing what you have to think about is, again, I've discussed this in a lot of free videos and course videos also. First thing, let's plot. Google is brilliant with these plotting tools. Sin x minus cos x. So the other way of looking at this problem is, if I want to find sin x equals to cos x, the other way of thinking about it is I want to find x such that, again, I'll write such that in short, such that cos x minus sin x is 0. Or sin x minus cos x is 0, whichever way you want to write it. I want to find an x where this is true. So let's plot this function and see where this is equal, even if it is equal to 0 or not. Again, I'm going to do a little bit of mathematical programming here, right? So let's go into it. So let's actually go and plot, let's say cos x minus sin x, because that's what I wrote in my notes. You can do either of them. Okay, very good. So when I see cos x minus sin x, it is equal to 0 at many places. Look at this. It is equal to 0 here. It is equals to 0 here. It is equals to 0 here. It is equal to 0 here. It is equal to 0 here. So Google, I mean, I love Google plotting tool for this. You don't even have to know matplotlib for simple functions like this, right? Now, let's say, okay, let's say I want to find this value. I want to find this x. There are many such x, obviously. This is one value of x, this is one value of x, this is one value of x, and so on and so forth. I want to find this value. So how do we write that? So let's go into our notes. I want to find one possible value of x that lies in 0, 1. Now, if you zoom this in little, if you zoom this in, right? Zoom this in. This is 0, this is 1. One value of x, let's call this function as f of x. Let's say f of x equals to cos x minus sine x, right? I want to find one x here in the interval 0 to 1. Look at this. In the interval 0 to 1, there is one x where f of x equals to 0. I want to find this number as accurately as possible. I want to find this number. How do we do that? With programming, right? So the question is very easy. One possible value of x. So I want to find x that belongs to 0, 1 in this interval. X should lie in this interval. This is a fancy mathematical way of writing it. Mathematical expressions, you should read them in English. You want to find x that belongs to this interval 0, 1. This is not a list, please. This is mathematical notation. This is not list. This is interval. It's very common to get confused between mathematical notations and computer science notations. This is the interval between 0 and 1 such that my f of x, which is cos x minus sin x is 0. Right? This f of x is nothing but cos x minus sin x. That's what I want. How do we find it? Any suggestions? Okay, I want to hear your suggestions. Can we draw the curve? Okay, somebody says 2n minus 1 pi by 4. How do you get that answer? Somebody says pi by 4. Cool. Of course, you can solve this numerically also. Okay, there are many ways to solve this. But I want a programming way. So right now I gave a simple function, cos x minus sin x. Right? I want a function where cos x minus sin x is 0. This is an easy function. But given any function here, I could give you any damn function. Given any function, fx, I want you to find x such that fx equals to 0 and x belongs to some interval a comma b. This is a general problem, right? This is often called as the root finding problem. Finding roots of an equation. If you remember root finding that you may have learned in your 8th class, 9th class, root finding basically means given an equation like this, find x that satisfies these values. That's what is root finding. Again, you may have learned this in your undergraduate level computer science. I'm sure that there is a subject called numerical methods, either in your maths 1, maths 2, whatever it is. For CSC, Ycja, I have seen this. When I studied BTech, we had this. I know it because it was compulsory subject for all departments. EEE, Mac, Civil, everybody had this subject, man. Every engineering guy had this. I think the subject was also there in MCA. Of course, MSc Math guys, MSc Stats guys will learn about this. No doubts about it, right? So the question is much more general. Somebody asks how to know if the code is optimal. If you can find a more optimal code than that, then certainly your code is not optimal. That's the simplest way to do it. Somebody says use divide and conquer. Can we loop over 0 to 1 with condition? Run a loop from 0 to 1 for sin x. Okay. Somebody says gradient descent. Let's not go to complex concepts. We'll do a live session later on gradient descent, where we'll learn about gradient descent methods, right? So I'll go to gradient descent later. Let's think of simple stuff. Somebody says binary search. Okay, how do you do binary search? Find the minima by differentiating. Okay, let's assume my function fx is hard to differentiate, very complex to differentiate. How do you find that then? Right? So again, by differentiating, how do you find fx equals to 0? You have to find fx equals to 0, right? How do you find, using differentiation, how do you find fx equals to 0? Think about it. Okay, somebody says, okay, a couple of good suggestions. Loop through 0 to 1 with an interval. Very good. That's a good idea. That's a good starting point. I actually like that. Again, let's use simple stuff. We'll learn more complex things as we go. So somebody says, let's do this. For I equals to, right? I'm just writing pseudocode. I'm not writing Python code. Let's take values from 0 up to 1, but take them in intervals of 0.01. So on and so forth. For all these values, let's just check. So let's define a function. Let's def f of x, right? Which will simply return cos of x minus, I'm writing pseudocode. This is not Python code because I'd write math dot all of that stuff, right? Now all this is cool. For I equals to this, just compute f of x. If f of x equals to 0, print x, right? Right? Can anybody think why this will fail? Can anybody suggest why this will fail? This won't work. I mean, this will not always work. Let me be precise there. It will work sometimes, but not always. It may not work for every fx. Why? Think about it. Any suggestions? Somebody says bisection method. We'll come there. But let's go to the intuition part first. Cos x by sin x equals to 1. I didn't say that, no? How did somebody say cos x by sin x equals to 1, tan x equals to 1, so x is inverse of tan of 1? The problem is cos x minus sin x, no? Not cos x by sin x. This is cos x minus sin x equals to 0. Right? So I think there is a confusion there. Because all numbers will not be covered. Good. So somebody got the good answer. So the question at our hand is, why won't this be true? See, here we are picking numbers with 2 decimal values. Probably fx equals to 0 at 0 point. Let's just make up this number. Okay, let's just make up this number. We don't know. 0.8123456712. Let's assume at this exact value fx will be equals to 0. So you will in this loop you will try 8.1, you will try 8.2, but you will not try this exact number. So this value will never be equal to 0. So how do you now solve for this? Okay. Okay. Because value can be any decimal places. That's true. That's true. Right? So how do we fix this? So we all know what is the problem with this. I'm happy we are thinking together. I'm very happy. How do we fix this problem? Think about it. Is there a simple fix to it? Okay. Any suggestions? The value may not be present in the range. Very good. People are thinking through it. Very good. Is there any all values do not occur in 0, 1? Yes. So can somebody tell me again, some of you who are good with trigonometry, who still remember, no, so actually, anyway, so I don't want to go into other topics of mathematics. Take value closest to 0. Very good, Sunny. Very good point. I'm happy you mentioned this. So one idea here is, just keep iterating, right? When you iterate, don't look for 0 exactly. Don't look for 0. Look at the value which is closest to 0. As you're iterating it, this is a very simple hack, no? A very simple hack. Now, one simple hack here is, one second, okay. One simple hack is, you just say the best till now. The best till now will be whatever, the best value till now, okay. The best value till now will be infinity when you start, or a very large number. You always check f of x. So the way you can modify this very easily here is, you say, okay, you will run through all these values, right? You will say, if f of x, right, it has to be as close as possible to 0, right? If f of x is, let's say if f of x is less than, or absolute value of f of x is less than the best value till now, the absolute value of best value, then your best value equals to f of x. You iterate through all of this. Look at this. So you're just keeping a best value that you're getting till now. Okay, best is f of x, and best x also you store as x. That's it. So now what do you do? Now what happens in this? You're just picking the one that is closest to 0. I hope the logic is right. So what does this say? This gives me, suppose let's assume f of x is 0.001 and my best is 0.1. Obviously it will pick this. I should always use absolute values here. Otherwise, negative values will overtake, right? So makes sense. Logically, this seems correct. But then there is a problem here. So let's assume the actual answer is 8, 1, 2, 3, 4. Let's assume. So we would surely try 0.81. Sorry, let me change the color here. So we would surely try 0.81. We would try 0.82. Either 0.81 or 0.82 will be closest. But this loop will run for 100 iterations. You don't know which are the, at 82 you can't stop. You'll have to go to 83, so on and so forth. If you want 2 decimal accuracy, look at this. If you want 2 decimal accuracy, this loop has to run through 10 power 2 or 100 values. If you want 3 decimal accuracy, this has to go through 1000 values. If you want 4 decimal accuracy, this has to go through 10 power 4 values. While this solution is a good solution, decent solution, its time complexity is a lot. Because if I want, let's say, d decimal values, I need 10 power d, I have to loop through this 10 power d times. Is there a better way than this? Well, this is a good suggestion, very good suggestion. Actually, I didn't think of this. I was thinking completely from a mathematics perspective, but it's a good suggestion, right? I didn't actually think of this solution when I wrote the notes. Oh yeah, I'll have to put exit. Why will you put exit? No, you can't put exit, no. If you put exit, everything will go for a toss. You can't put exit. So at the end of this, you'll just say print x and fx. Again, this is not perfect syntax because you got 8.82, but it could so happen that 0.99 is closer to the f of 0.99 is closer than 0.82. You don't know that, right? So you have to try all these values. You can't skip any value, right? You just go through each of them, find the best one, and you continue. That's a problem with this solution. No, how do you know you got the solution? You don't know that you got the solution yet, because there could be other values which could be better than that, right? My 82 need not be the solution. Suppose let's assume that depends on f of x, obviously, right? You still don't know that. That's a problem. But there is a hack around it. I know what you guys are going to. So if you plot this, if you see this plot between 0 and 1, this is monotonically decreasing. What does monotonically decreasing means? So let me just zoom this out, zoom this till here. So if you look at these values from 0 to 1, it is continuously decreasing as you are going from 0 to 1. This is continuously decreasing, which means once you come close to 0 and as you keep going away from 0, look at this, as you keep going away from 0, you will not come back to 0. So some of you are right that once in this we have to find a pattern. In your code, you have to say, okay, we know that it is a monotonic function. What is a monotonic function? Monotonic function. A monotonic function is either something which is continuously decreasing or increasing. Again, it need not be linear. It can be any shape. Sorry, this is not there. As I'm going from 0 to, let's say, 0.82, these values reduced from 82. So there is a decrease. From 82, there is an increase. So you find that point from where, look at the distance from 0, the absolute value distance from 0. You are plotting the absolute value, right? You say it is decreasing and then it is increasing. Or in other words, this value, you don't even have to worry about that. These are all positive values, these are all negative values, right? So just find that x. Just find that x where you go from positive values. Just find that x wherein you go from positive values to negative values, right? The moment you go to the negative value, you can just break this, just write a condition here and break this, then you don't have to go any further. But in the worst case, what will happen? Look at this. In the worst case, imagine if your f of x crosses from positive to negative at 0.99. Then you will have to go through everything. What you're doing here is often called as a linear search. Again, this is something that we discussed in our course videos also. You are linearly searching for your answer. You are searching at 0, 0.01, 0.02, so on and so forth up to 1. One after the other. This is called as a linear search, right? A very common concept in computer science also. Now, a better way than linear search is binary search. Again, this is something that I explained in the course videos when I explained about computational complexity, right? So what does binary search say? Again, we can solve this problem better using binary search. That's the idea here. Again, the reason I gave this problem here is to connect the concepts in computer science like linear search, right, and binary search to mathematical programming. Again, as a machine learning engineer or as a data scientist, people expect you to be able to solve these mathematical problems. You may not know dynamic programming, all the advanced data structures, but people expect you to come up with reasonable solutions and even code for this. Again, a small variant of this is what I've asked people in interviews. I don't ask because software engineers are there to do software engineering. Machine learning guys should be able to solve mathematical problems and mathematical code related problems also, right? So what is the idea behind binary search? Let's see. The idea is very simple. Let me explain the idea. But I think some of you also mentioned this, that we can use, somebody says divide and conquer. Yes, divide and conquer is a concept which is used in binary search. Somebody mentioned bisection method. Again, bisection method is nothing but a different name for binary search in the context of root finding. It's just a different way of looking at it. That's it. It's the same concept more or less, right? So, okay, so there fx equals to 0, plot cos x and sin x, the intersection value of x for x is 0. Again, somebody says that you will plot cos x and sin x, the intersection value. How do you see that? You will have to, again, I don't have to do that, right? I can do cos x minus sin x, zoom this in, zoom this in, zoom this in. I can zoom it in, right? Okay, I found 785. Okay, zoom it in further, right? If I want 4 decimal places, I can plot it, zoom it. But then this requires, okay, this is somewhere between 78535 and 7854. So the answer probably is, if I want 4 decimal places, right? Okay, so let's zoom in a little. Okay, so, okay, somewhere like this, 75, okay, if I go here, it will tell me. Okay, look at this. Look at this value here, right? So what does it say as I'm coming closer to this? Okay, it says 7853. Roughly that's the answer. You can always do it from plots, but programming is much more fun than that. Again, it requires human intervention. Imagine if this solution has to be an input to some other function. Then you can't say, let's look at the code, right? Okay, so somebody says continuously find the mid value. Yes, you're right. I'm happy that all of us are thinking together. The idea is this. I start between 0 and 1. Again, a key observation that we have here is that this function is monotonic in this range. So it goes from positive values to negative values, and 0 is exactly on the boundary, right? So let's solve this. Between 0 and 1, first what I'll do here is this. I'll say, what is f of 0? I know f of 0 is positive, all right, right? I know that. I know what is f of 1. F of 1 is negative. So which means the answer, because the curve is falling like this somewhere, the answer has to lie somewhere in between. So how does binary search work? I take an array. In binary search, I take an array, I break it up into 2 parts. In the next iteration, I only use either the first half or the second half. That's what I discuss in binary search, right? That's the concept of binary search. Even here, we'll use the same technique. It's the same concept applied to numbers. So what do I do now? Okay, now I say, let's take the middle point. Okay, the middle point, let's compute the middle point. The middle point is 0.5. Now I say, at 0.5, is it positive or negative? At 0.5, if it is negative, look at this, at 0.5, if it is negative, that means the answer lies in this window, somewhere in this window, right? If at 0.5 it was positive, then the answer lies in this window. So in our case, look at this. So I'll call this as the x lower limit. I'll call this as the x upper limit. I'll keep changing these lower limits and upper limits, just like in binary search, right? So let's go through the logic. I want to go through the logic with you by walking you through the code, okay? So let's see, let's go through again, I'll keep this diagram here. First and foremost, very simple. I just import math. I say return math.cos x minus math.sin x. Don't forget to put import math and use math, because cos x is not an inbuilt function. You have to import math. So I'm defining my f of x. Cool, very simple. Then what am I initializing? My lower limit, I'm initializing it to 0. My upper limit, I'm initializing it to 1 because my initial window is 0, 1. That's my initial window. Next, I'm computing the middle point. How do I compute the middle point? XU plus XL by 2. That gives me my middle point. Now, look at this. Now I'm doing an iterative part, right? How does my iterative part work? This is important, right? If fx, see, if I want 3 decimal places, if fx is greater than 0.001, again, there is a small bug in this code. I'll tell you what later. Okay, I want you to figure out the bug, by the way. Okay, so if fx is greater than 0.0001, right? So my f of x is like this is like at 0, but I'm okay. Getting perfect 0 is hard. So I want, let's say, 3 decimal places. I want the 3 decimal places type of accuracy. First, again, whenever you write code like this, keep printing to know what is happening in your system, right? So if your f of x is greater than this, right, then you'll keep iterating. So what am I doing here? First, I'm computing the middle point. Look at this. I'm computing the middle point. If at the middle point, so this is my middle point, right? So this is my x here. This is my XL, this is my XU, this is my X. This is my middle point. X is always the middle point in this loop, right? If f of x is greater than 0, look at this. If f of x is greater than 0, right, which means this, if this is greater than 0, what happens? My area that I look at should be this window. Then what should I do? I should make the current x equals to my XL and I don't touch my XU because I want to focus on this region. If f of x was positive here, look at this, if f of x was positive here, I know that the answer will lie in this region. If f of x is negative, I know that the answer lies in this region. So what do? I compute x. If f of x is greater than 0, right? If f of x is greater than 0, I make the lower limit equals to the current x. I don't touch the upper limit. But if f of x is less than 0, look at this. If it is less than 0, I know that my answer, this is my answer, right? My answer I know lies in this window. That's why I'm adjusting only the XU. Then XU becomes this. So this becomes my XU. My XL doesn't get interrupted. So what I'm doing here is, given an interval like this, with each iteration, I'm breaking into, see, I'm saying either the answer lies in this interval or in this interval. If I know it lies in this interval, I'll break this further. I'll check whether the answer lies in this interval or in this interval. If the answer lies in this interval, I'll again break this interval into half. This is the whole idea of binary search, right? That's all is the code here. There is nothing more fancy. See, I'm printing this line and this line to see how things are progressing, right? The moment you execute this code, okay, let's execute this code. The moment you execute this code, initially XU and XL. Again, the reason I print is because I want to understand what's happening. XU, XL are 0, 1, cool. Then I'm printing f of x, cool. My f of x I'm printing. But since this code has executed, what does it do? Since my f of x is positive, look at this, my f of x is positive, right? My x is 0.5. Look at this. My f of x is positive. My x, look at this. This is my XL. This is my XU. This is my x. My f of x is positive. Look at it, my f of x is positive, right? Which means this should become my interval, right? And that's what happens. My interval becomes 0.5 to 1. Very good, right? Look at this. XL and XU have changed to 0.5 and 1. It's working well. Then in the next iteration, my XL is 0.5, my XU is 1, right? Now it takes the middle point, computes the middle point, and it prints this. Cool. This is also printed. Now the value is f of x is this. My interval has become 0.75 to 1. So I start off with 0, 1. Then this is my starting first iteration. This is my second iteration. My third iteration is 0.75 to 1. Cool. Things are working good. Then I know that because if you look at this, okay, let me just scroll this a little down. Okay, without showing you the answer. Let's go down here. Next I get 0.75 and 1. Okay, cool. My XL and XU are behaving as I expect. Now I print the value at 0.75. At 0.75, what do I get? Look at this. At 0.75, or the middle point, I compute the middle point, right? 0.75 and 1, the middle point is what? 0.875. At 0.875, I compute. What do I get? I get minus this value. Right? What is my XL now? This is my XL. This is my XU. And what is my X now? My X is 0.875. Immediately after this, the loop terminated for some reason. Right? And it says X equals to 0.875 and f of X is minus 0.1265, which is not what I want. I want it to be close to 0. This is still far away from 0. What is the error in this code? I want you to guys think about it. Okay, this code is in front of you. Let me know. I've written the input. So I've shown you the code. I've explained the code. I've also explained the output. Syntactically, there is no error. It's running. But there is a bug. There is a logical error here. So can somebody tell me what is the logical error here? While condition. What is the error in the while condition? Somebody says there is an error in the while condition. Can somebody tell me what is the error in the while condition? Look at this. I hope, again, let me show you this. Okay. Again, there are many ways of writing this. This is just one way. I wanted to make an error. Again, it's sometimes hard for me to explicitly make errors because it takes me a couple of seconds to think of what errors can especially beginners make. Right? So it takes me a couple of minutes to think of errors because if I were to write it, I'll have far fewer errors than this. Okay. F of X is greater than, come on, this won't work, no. Somebody says that we have to put one second. Somebody says we have to place an absolute value here. Why absolute value here? Absolute value of 0.001 is 0.001. No problem with that. That won't work, no. Again, you're thinking correctly, but there's a bug still. Somebody says f of X has to follow this. Okay, cool. I'm happy. Use absolute value. Yes. The problem here is this f of X must be inside an absolute value. Because if you don't use absolute value, the moment f of X value becomes negative, this negative number is less than 0.001. It will come out of the loop. Look at why it came out of the loop here. It came out of the loop here because this value, the negative value is less than, f of X is greater than this. While this is true, it will keep going in. So this f of X value is less than 0.001 because this is a negative value, this is a positive value. That's why it came out of the loop. So what we should do here is we should use absolute value. I wanted to drive that point. So the moment you use absolute value, okay, so what did I do here? I said import math.absolute value. I executed this. I get an error. Again, right? Again, I'm trying to cover as many errors as I can. Okay, please understand that. I got an error. Let's read through the error. Okay, it says, where is the error? It says the error is here because that's the only line I changed. It says module math has no attribute ABS. What is the error here? Come on, it's trivial. ABS function is not in math. That's what it's trying to tell you. Right? Again, we've seen this a very common mistake. People think absolute value function is in math. It's not. And that's what I wanted to drive. Absolute value is inbuilt into Python. You don't have to use math.absolute value. Just say absolute and that's it. You get the solution. Right? So, was this not executed? I thought this was executed. Okay, let me just execute it anyway. Let me just run this. Okay, you get the solution now. So look at what you get here. So you keep going through, you start with 0.1, then you go to 0.51, then you go to 0.751, 0.75, 0.875, then again bisection. Finally, you get X equals to this value where it has, look at the first three decimal places. First three decimal places are 0. It is only in the fourth decimal place that things have changed. If you want more accurate answer, look at how many iterations did it go through? 1, 2, 3, 4, 5, 6, 7, 8. 8 iterations, that's it. If you want more iterations, for 3 decimal places using this method, it would have gone through worst case 1000 iterations. Worst case, not always, worst case. In this, with just 8 iterations, we got it. Even if you want 4, we can just run it. It might take maybe how many iterations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just 12 iterations. We already got something which is 10 power minus 6. E minus 6 basically means into 10 power minus 6. Very good answer. Very good answer we got. With just 12 iterations. right? Cool. Now I want you to solve this problem slightly differently. Okay, this method is called as bisection method, and it uses binary search. Binary search is something that we discussed in our course videos. Very simple concept. Again, it's often taught as a first method of divide and conquer. This is also a divide and conquer approach, because what are we doing? We are taking an interval, we are dividing it into two parts, right? And we are only looking at one part. So we are using divide and conquer here, right? So this is a very important strategy in algorithmics design that we are using here. Now I want you to go through this, okay? Exercise, okay? Solve a problem like this. Again, follow the same steps as above. Always see it in Google Sheets. Again, you can plot this. Solve the same thing. Whatever we have done here, just change f of x and c. I want you to just change f of x and play. Now there is a better method. The bisection method is not the most optimal method. Again, there is a whole area called numerical methods. Again, I studied this topic extensively, and there is something called as rate of convergence, right? Again, I'm not going to go into the mathematical details here. Rate of convergence basically says how fast are we moving towards the x that we want. That's what is called as a rate of convergence. Numerical methods, the time complexity is measured by rate of convergence. How fast you are moving towards the x that you want. Again, bisection is a very simple method. There is a better method that some of you may have learned in your BTech called as Newton-Raphson method, which is far faster than bisection. I've provided links for you. Brilliant has a very nice explanation of Newton-Raphson. It requires you to have basic understanding of derivatives. Again, we have one problem on derivatives little later. If you don't know that, probably after tomorrow's session, you can easily follow this. There is also code in Python that I've put here. Again, we will cover some of the concepts behind Newton-Raphson method when we do a live session on optimization. So in our course videos, again, as part of this live session, as time permits, we'll go around and learn about gradient-based methods, how to use derivatives to find the zero there. How do we do that? Again, you can use derivatives to solve that. There is a way to do it. It's not straightforward. Again, literally, some of the best mathematicians of their generation, both Newton and Raphson, came up with this method. Imagine this method, they came up in 1600s, right? They came up in 1600s, and it's still one of the most popular method. So there is something called as gradient-based methods that we will discuss in one of the future live sessions when we cover optimization methods, where we'll implement gradient descent, stochastic gradient descent, batch gradient descent, right? We'll implement all of them one by one, right? So for now, this is the takeaway. Sounds good. We have 25 minutes, right? So let's try to solve this problem. Okay. I think we can solve it. Let's try. Okay. This is my problem. Okay. Again, this is a problem in mathematical programming. The problem here is given a function like this, sin x by x. First, let's plot it. I want to find the area under this curve in the interval -10 to +10. Okay, I'll explain the mathematics. Don't worry if you don't know this. First, let's plot sin x by x. It's a beautiful function actually. Sin x by x is a very beautiful function in mathematics. Okay, you might have seen this function. So sin x by x has this nice thing where this is high peak, then you have other peaks. But as you're going this way, the x is increasing, right? Look at this, the x is increasing. So sin x value always lies between +1 and -1, right? So as you're going this side, the denominator is increasing, while sin x oscillates between -1 to 1. Right? Sin x always oscillates. Sin x oscillates like this, right? So if you just plot sin x, it oscillates between +1 and -1, right? So sin x itself oscillates between +1 and -1, but the denominator increases as you go this side. Similarly, the absolute value of the denominator also increases as you go this side. So this function is very beautiful. It's extensively studied. Now my question is this. I want to find the area under this curve from -10 to +10. What is called as the area under the curve? That's an important question. This whole thing. So this whole thing. This is called the area under the curve. This whole thing. Area under the curve is nothing but the area between the x-axis and the curve. So this whole thing. Similarly, this whole thing. This small part here, this small part here. I want to find how much area is there. Again, finding area of rectangles is simple. Area of circles is simple, right? Area of rectangles is also simple. You can find area of triangle also. Now here you have a complex curve for which you want to find the area under. How do you solve this problem? Think about it. I want to hear some of your suggestions. Okay, one second. Integrate with limits, okay. Can somebody integrate this for me, please? Can somebody compute minus 10 to plus 10 sine x by x dx? Integration. You all must have learned it in 11th and 12th class, right? Can somebody integrate this for me? It's not easy, trust me. Forget about this integration. This integration is much harder. Even if you do 0 to infinity, sine x by x dx. Again, if you have forgotten calculus, don't worry about it. Even if you want to integrate from 0 to infinity or minus infinity to infinity, it's not trivial, trust me. This is one of the very interesting and challenging integrations to compute. This is what? Minus infinity to infinity. From minus 10 to 10 is much harder. Again, you can just Google search for it and you'll see that there are actually 20-minute videos on how to solve this integration. There's something called as a Feynman's method. Again, I didn't learn this in my 11th and 12th. I learned it later when I was learning some advanced mathematics, right? I think there is I think for this problem only, no? So let me just Google search. I forgot. Integrate Feynman. I think there is a Feynman's method. Oh yes. Oh, this guy is very good. He does some good, beautiful math. Yes, you can use something called as Feynman's method. Yes. So there is this beautiful. Okay. So anybody who has time, since we are anyway in a lockdown, so read this beautiful math book called Surely You're Joking, Mr. Feynman. Again, for those who don't know, Surely You Are Joking, Mr. Feynman. For those of you who don't know, Feynman is considered one of the greatest minds of 20th century physics, Nobel laureate, physicist, most importantly a great teacher. Right? This is sort of like his. He's a phenomenal guy. The reason I love him more than, I don't understand his physics because I have not studied quantum thermodynamics and all that. But the reason I love him is because I still have these books. I think you must have encountered this in your 11th and 12th class, right? Feynman's lectures. The first stipend, my salary as I call it, the first salary that I ever got as a stipend at an Institute of Science, I bought these books. These are called lectures on physics. I studied them in my 11th and 12th class. Some of the best books. These are actually his lectures, which are written as books and published. Phenomenal books. I love his explanation. He's like the role model for anybody who wants to be a teacher in science and engineering and mathematics. Phenomenal guy, right? Anyway, back to our topic. So integration is hard. Okay, if you try to do it using integration, hey, I think there is a typo here. I wanted to. Okay, so first plot it. Okay, I wrote Gogol here. Again, Gogol is a Russian author. We should actually use Google. Russian author who has written some very interesting work. Anyway, back to our topic. So you can't integrate it easily, right? So 1 second, Russian. Man, there should be some typo check for IPython notebooks because I am so bad. I'm so used to Google correcting me for my typos. Anyway, back to our discussion. How do we do it? Integrate a function from minus 10 to plus 10. How do we solve this? Again, your job is, again, the point I'm trying to drive here is, you're given a function, fx, and you want to find the area under the curve. As some of you pointed out, I want to compute this integral. This is called finite integral. From a to b, I want to compute this. 11th and 12th class, we studied that integration is nothing but area under a curve. All that is cool. But sometimes f of x can be extremely hard to integrate. Differentiation is easy. Integration is much harder, folks. There are some functions which are extremely hard to integrate. But integration is something that is important in computer science. Again, You might wonder, why the heck are we learning all of this calculus stuff now? So in machine learning, as we discuss in our course, there is something called as an receiver operating characteristic curve. And we have to compute the area under the curve. Very often we just call a function which computes the area under this curve. So one of the favorite questions that I used to ask in interviews, programming questions, is, okay, everybody knows about ROC, area under curve and all that. I say, hey, can you write a program to compute the area under curve from first principles using simple mathematics without using any inbuilt functions? I've seen guys who can tell me everything about the mathematics who can't write this code. And this is literally 11th class, 10th class mathematics. Okay. So it's important that your foundations are also strong. Again, we discuss the intuition behind integration in our course videos. But since we are not yet there, for the interest of everyone, I'll rediscuss this. Okay. First and foremost, I've taken some beautiful images from the computer science and mathematics department at Emory University. So phenomenal. So please go check this. I'm simply borrowed this diagram from there because they've drawn it very well. It's a brilliant blog. I want you guys to spend time and read it. It's a way, he talks about, again, he says this is high school material. This is high school material in US. US math is much, at least high school level math is easier than India's high school level mathematics, right? So it's actually very simple. Okay. So the idea here, okay, let me just describe here itself, right? Makes logical sense. So the concept behind integration is, if you have a curve like this, f of x, if you want to find this highlighted region between a and b, one way to write it mathematically is this. This is just mathematical notation. This is just mathematical notation. This is the intuition. This is the geometric intuition. Unfortunately, I see a lot of people who know these notations who have either forgotten or don't know this intuition. This is just a concise way of saying I want the integral under f of x or between f of x and x-axis from a to b. Instead of writing that long sentence, people write this. I want to integrate from a to b f of x dx. This is just, again, as I told you, right? This is a concise way. This is like poetry. In poetry, you take a beautiful concept and explain it simply and concisely. This is just a concise representation of saying, I want the area under this function or between the function and x-axis from point A to point B. I want this. This is just a notation. A lot of people panic as soon as they see the symbol. Don't panic, it's simple. Like area under the curve, guys. That's all it is, okay? So now how do we do this? Any ideas? Okay, I think I have already shown the solution, but any ideas? Okay. Somebody asks, do we need to write everything in code? No, you don't have to write. As a machine learning engineer at companies, most likely you'll use libraries to do this. But the reason interviewers ask this, now your immediate question should be, why the heck are interviewers asking these questions, which anyway I'm not going to use? Because interviewers want to understand your foundational knowledge. And if you can think about a problem from first principles, that's what they want you to think about. Right? That's very, 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 very important. They don't want to, again, there is this other criticism that I often see because I've done so many interviews. People say, anyway, we are not going to solve, again, for software development engineers, right? There are tons of questions on data structures, algorithms, all that are asked. But a typical software engineer, even at a top-notch company like Google or Amazon or anybody, do not use any of them. I think there are only a few instances in 10 years of all the software code that I've seen. There are less than 10 instances where I have actually seen dynamic programming used, dynamic programming that somebody had to implement. And I've seen tons of code. Okay. So then question people ask is, why the heck do we ask data structures and algorithms for software engineers? The logic here is to understand more complex systems. If you want to understand Hadoop, perfectly internals. If you want to understand how Hadoop works internally, you need to know, again, you can have a surface understanding of Hadoop or Spark or all of these things. Or you can have a deep understanding. I've worked with some of my software engineers in my team who are phenomenal. They literally open up the whole source code of Hadoop and understand every nitty-gritty bolt and detail. So to understand something like that, a strong foundations in data structures and algorithms are important. Because what companies like Google or Microsoft or Amazon want you to do is, they don't want you just to use some library. They want you to be at a skill level where you can build a system like Hadoop from scratch. Number one. Number two is they want to test your problem solving skills. How well, given a real world problem, how well are you able to solve this problem using simple foundational concepts, not some rocket science concept. There are literally like 20 concepts in computer science, basic concepts. If you know them, you can solve every damn interview question at any company. Like for software engineering roles, machine learning, there are more concepts without doubt. But for software engineering, there are literally like 20 concepts, like dynamic programming. Even in graph algorithms, they just use graph traversals and graph search, or mostly graph traversals only. Nobody asks the shortest paths, all of that. They might ask you a little bit of flow problems. I can literally write it down. There are no more than 20 high-level concepts that are required to solve 95% plus of software engineering interview questions. But they ask you this because they want to see how you think. They want you to understand how well can you think. Again, the reason I used to ask questions like these in interviews is not because I expect this guy to implement sin x by x integral from -10 to +10. Like if he was actually doing this on his job, I would actually want him to bloody use some library, because the library implementation will be far better than what a machine learning engineer would implement. Forget about machine learning. Even if a software development engineer is doing it, I would ask him to use a library, because there could be some bugs. A library function is well tested, well used, all of that stuff. Why should he again re-implement it? I don't want them to re-implement it, but I want them to have the ability to build the whole library if required. Right? I want them to have the foundational skills. That's the important part. That's why interview questions like these are asked. Like I've never had to write area under the curve in the 10 plus years that I've worked in the industry. I never had to write. But interviewers ask because they want to understand your foundational knowledge, and they want you to understand how you can break a problem and solve them, your problem solving abilities. Again, a very, very important skill is problem solving. People don't realize it. And problem solving skills are transferable. This is what is called as transferable skill. What is a transferable skill? If you're good at problem solving in one topic, right? Like for example, if you're good at solving, let's say, let's take an example, aptitude problems. Okay, this is a good example. I get asked, if you're good at solving simple aptitude problems just require high school level math, right? Just high school level math, nothing major, not even calculus. If you're good at this, problem solving skills are transferable, which means tomorrow if you have to solve another problem, suppose if you have to solve a business problem, not even a technical problem, right? Or tomorrow, let's assume you have to solve some marketing problem or some sales problem, right? The problem solving skills are transferable, which means if you read enough business books, if you learn the basics of business, the problem solving ability that you learned solving aptitude problems can be used to solve business problems also. Why does the CAT exam? CAT is a very popular exam in India, right? CAT exam, what does CAT exam consist of? Simply aptitude reasoning and English reading, right? Aptitude reasoning. This is for a business school. Aptitude reasoning and English, basically vocabulary and all that stuff, right? Why? For business, the logic is, again, these guys are, the people who are conducting the CAT exam are not fools. They're fairly smart. They know that somebody who is strong in aptitude and reasoning, if we teach them basics of business or marketing or sales or anything, they can transfer those strong problem solving skills to other domains. Why do they test your English? Because as part of your business school, you have to read lots of books and case studies, right? Similarly, when a company interviews you, they're literally testing for your problem solving skills. They're literally testing you this. Any exam in the world, anywhere in the world, they're simply testing for most of them. At least this is one of the core skills that they test, which is problem solving. Like take GRE or any exam, right? They have aptitude, reasoning, and they also have English, because they want people to be able to understand English, to read English, comprehend English, right? So it's the same concept. Now, I think we have 8 more minutes. So we'll continue this question tomorrow. I will give you till here. I'll give you the links till here. We'll discuss how to solve this problem tomorrow. I wanted you guys to come up with, okay, some of you have already come up with answers. Let's discuss it anyway. Okay, rectangle is used to cover the area under the curve, blah, blah, blah. Okay, good. Some of you are coming up with answers. Good. Find crest and trough between the limits, determining the highs and lows, small areas like trapezoids or rectangles. Yes, some of you got it right. It's a very simple concept. Okay, let me explain the solution. Again, this diagram is also taken from Math CS Emory. Very simple concept. So I want to integrate from A to B, right? Take A. Compute f of A. I can compute f of x, right? Compute f of A. Then I take a small width. Okay, I take a small width. Imagine this whole interval from A to B. If I break it up into n such intervals, then what is the width of each interval? B minus A by n, right? Let's call each of these intervals delta. Okay, let's call this as delta. Let's call this as delta. This interval is delta. So what do I do now? I am going to approximate this whole area from here to here. I'm going to approximate it by saying, I know how to compute the area of a rectangle. Very simple. It is basically your height multiplied by width. So I got the height here. This height I'll multiply with this delta. I'll keep the delta to be very small. Okay, let's assume delta is small. Then what happens? I get this area. If I multiply A into delta, what do I get? I get this area, right? Next I reach here. What is this x value now? This x value is A plus delta. I can compute f of A plus delta. Delta is nothing but width in this diagram. Again, I'm using the terminology delta because I wrote the code based on that. Okay, it will be easier for us to understand. So A plus delta, right? This is A plus delta. So what is this? Now I can compute f of A plus delta, and that will be this height. I got the height. Look at this, I got the height. Now this width is nothing but my delta. So this area is now nothing but f of A plus delta multiplied by delta. This is f of A multiplied by delta. F of A multiplied by delta. So f of A multiplied by delta plus f of A plus delta multiplied by delta, not A, multiplied by delta plus, what is this now? This is f of A plus 2 delta. What is this height now? Now look at this. Some heights are shorter than the curve. If you look at this height, I'm leaving this space. Look at all the space that I'm leaving. I'm leaving this space here. I'm missing this space. I'm also missing this space. But with respect to this, I should only have covered this space. But there is additional space that is covered. Even here, the space should only be this, but I'm getting additional space. So what's happening here is, I'm missing some space like this, and I'm covering some additional space like this, right? So the area that I'll get here is an approximate area. The area that I'm getting here is an approximate area. How do I make the area closer to the actual area under the curve? If I make this width smaller, if I make my delta smaller, or in this formula, if I make my n larger, look at this, b minus a by n. B and a are constants. In our case, it is minus 10 and plus 10. If I make n larger, the width becomes smaller. Width is nothing but my delta, right? As I increase the number of these intervals, which is nothing but n, or if I make the delta smaller, look at this. If I make it smaller and smaller, what will happen? The error, the missed out area or the overly covered area, they both will reduce. So the solution here is nothing but simply just write a simple for loop. Look at this, write a simple for loop here. That's it, right? Okay, here is a good example, Again, I'll skip the code. We'll discuss the code tomorrow, the first thing, right? Look at this. Again, same image from Math Emory. Look at this. If my interval is large, I'm missing this whole area. Large area is missed. But instead of two intervals, instead of having two, if I have 8, which means my delta has become smaller here. If I have delta smaller, lesser and lesser area is being missed out, right? So I can easily compute the area under the function f of x dx, right? I can easily compute this by taking smaller and smaller regions, by taking a delta which is small. Actually, if you think about it mathematically, what is dx? Those of you who remember. Again, we'll go over calculus again when we touch the calculus topics in our course. What is dx? Dx is nothing but delta x. It is nothing but delta x. But delta x, as it becomes very, very small, a minuscule or infinitesimally small delta x is what is called as dx. Now, this is what we write in calculus, right? The other way of writing this in calculus, again, I think I described this in the course videos when we learn basics of calculus and optimization. So the other way of writing this is same as summation f of x into delta x. Look at this. F of x into delta of x. Delta of x is nothing but a delta here. F of x into delta x, where x is from a to b in the intervals of delta x. Right? This is what it is, right? Again, I'll explain this with the code. Integration is assuming that integration is basically assuming that each of these is infinitesimally small, very, 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 very tiny. The equivalence of this integration, if you want to write it, is you can write it as you multiply f of x with delta x. Suppose if this is x, you multiply f of x with delta of, this is f of x, right? This is f of x. This f of x you multiply with this is delta x. Multiply f of x with delta x. What do you get? You get this area. You sum up this area. You sum up this area from x equals to a to b in the intervals of delta x. Right? Which means you first do it at x, then you do it at x plus delta x, then you do it at x plus 2 delta x, and so on and so forth. So whatever integration problem is there, you can break the integration problem into a discrete problem. Again, there's a whole discrete mathematics and continuous mathematics, but you can think of it as adding up areas under these smaller rectangles. Now what I want you to do, again, when I share the document, I'll stop it here, right? Since we are anyway run out of time, we have just a couple of minutes. I want you to guys to write the code for this. Write the code. And also I'll ask you a question. How do you check that your code is correct? You might write code, it will give you some answer. How do you check that your code is correct? I want you to think of both those things, and let's join the discussion again tomorrow. We'll continue where we stopped off. I'll walk you through the code for this. This is just an assignment for the evening, right? Again, I have fifth problem also. I'm happy that we have covered 3.5 problems today. Tomorrow probably we'll cover more. I hope this is good, right? Yes, good. So what I'm saying here is integration is continuous, summation is discrete. Anyway, I wanted to explain that tomorrow in more detail, because we have anyway run out of time now, right? So just try to write it down. Somebody says, okay, let me answer a few questions. What is the daily lifestyle of a data analyst 2 to 3 years? Is it satisfactory or hectic? Depends on the company you join, right? So you might join a company where the work is chill, where your growth is also not very fast. So in such a case, you're not learning much. Especially early in your career, I would suggest you join companies where it's a little hectic, not overwhelmingly hectic, slightly hectic, where you have good mentors, where you learn a lot. Because what you learn early in your career will take you a long way. I have learned a lot, right? So somebody asks how to improve problem solving skills by solving more problems. There is no escaping that fact. There are two ways actually. Good question, Ashutosh. First is solve as many problems. Yesterday I gave you a list of hundreds of problems that you can solve, right? You solve more problems and you read, again, you should, it's like exercise, right? As you pump, as you do more exercise, your muscles become stronger. Problem solving is very similar. As you solve more and more problems, there is no escaping that fact. I remember, I think in my BTech first year, I wrote at least a few hundred programs to become a good programmer. I wrote all of them in C, right? So the way I became a decently good programmer in my BTech was by writing hundreds of programs. There is no escaping that. Again, there might be some of you who are smart, who don't require, again, the amount of hard work differs from person to person. Some of you may have very good aptitude skills. Some of you can figure it fast, but I think everybody has to do some amount of problem solving. That's one. Give every problem ample time. And if you can't finish it, If you can't solve it even after you've given a day or two, then read the solution. Ask yourself why you are not able to solve it. That's very, very important. Okay. So somebody says, should I leave my job if I'm not learning? Please don't leave. Learn on your own time, get another job and then leave, right? Or somebody says hacker rank problems are needed. Again, hacker rank problems are meant for software engineers. Some of the easier problems on hacker rank are certainly helpful for machine learning roles, but you don't have to be an expert in everything. Again, there are some product-based companies, especially if you're a computer science student. If you have studied BTech computer science or MTech computer science, if you go to a product-based company, you will have one round with data structures algorithms. If you're a non-computer science student, they could excuse you, right? Especially in top product-based companies, okay? But that will just be one of the many rounds. You typically have 5 to 6 rounds. Most of them machine learning. There might be just one round. There typically will be one round for data structures algorithms, right? Okay. So again, the time that you have to spend depends on person to person, right? Again, today I'll give you an example, right? And over time you become better at it. Today I can read research papers fairly fast because I've done it for almost 13 years now, since my MTech first year. I was extremely slow when I started. It was extremely hard, excruciating part, but you become better over a period of time. I've been consistently putting day in, day out efforts, and that's how you become better, right? So please understand that. Again, I'll share the document for this live session in about 10 minutes. Please give me 10 minutes. I'll share that under the live session itself, in the comment section and the description section. See you folks. Thank you very much. Okay, see you. That's all I had. Yeah. So see you tomorrow. We'll continue where we left off and solve more interesting problems.